Welcome. In this video, we are going to estimate the area of this region depicted using a Riemann sum with n equals 4 rectangles. Then we're going to find the exact value of the area of this region using integration. So let's get a handle on what we're doing. We can use integration to find the area between these two curves. And remember, when you're finding the area between two curves, of the area of a region that is, you want to subtract one from the other. In order to figure out which one to subtract from which, it helps to get your pencil. And here's my pencil. And so here's my pencil. If I was moving my pencil along this line vertically, I could see that 9 here is more positive than the y values of 3 to the x. In short, we can say that this line, y equals 9, is always bigger than this curve, 3 to the x, on this interval from 0 to 2. Okay, so that means I'm going to write 9 minus 3 to the x dx. And this interval of intersection goes from 0 to 2. 0 is the lower bound of their intersection. That's the lower x value. 2 is the upper bound of their intersection. Now we can estimate this using 4 rectangles, and I'm going to use midpoint, so the middle of each rectangle, and I'm going to denote that M4, and that's going to equal the sum from I equals 1 to 4 of delta x times 9 minus 3 to the xi dx. And xi is the midpoint of each region. So let's go ahead and figure out what these midpoints are. And what delta x is equal to the max of the interval minus the min x value of the interval divided by n. So the maximum x value is 2 minus 0 over 4. So that tells me delta x is equal to 1/2. So this will be the base of one rectangle. This will be the base of the second, the base of the third rectangle, and here's the base of the fourth rectangle. I'm going to move this so it's, there you go, that looks more accurately midway between 1 and 2. Now we want the midpoint of each. And you know what, let me fix, instead of saying each region, I should say of each subinterval. To be clear, this is the region, this is the interval, and each of these is a subinterval. Let's find the midpoint of each of these subintervals. As you can see here, our subinterval is 0.25, that's a quarter. This subinterval here is 0.75. This is 1.25 and 1.75. And that's just the midpoint. If this is 1/2, this is the midpoint from 0 to 1/2. 0.75 is the midpoint from 1/2 to 1. 1.25 is the midpoint from 1 to 1.5. And 1.75 is the midpoint from 1.5 to 2. Okay, so let's keep going. So I labeled this row is star, so we can continue here with star, is going to equal delta x times 9 minus 3 to the x1, where this is x1, plus delta x times 9 minus 3 to the x sub 2, clearly this is x2, plus delta x times 9 minus 3 to the x sub 3. I think you can see that this is x sub 3, and I'll just go ahead and label this x sub 4, plus delta x times 9 minus 3 to the x sub 4. In this next step, I'm going to go ahead and factor out delta x. They all have a delta x in common. And additionally, I'm going to replace delta x, which is its value, and that is here. And I need to make a quick fix. I just wrote delta. We actually have a delta x here. So this is 1/2 times 9 minus 3 to the 0.25 power plus 9 minus 3 to the 0.75 power. plus 9 minus 3 to the 1.25 power plus 9 minus 3 to the 1.75 power. At this point, we can get a calculator and work out these values individually. Now, in order to remain as accurate as possible, I'm going to go ahead and add these all up. But I'm going to add up the exact values on my calculator. And now dividing this by 2 gives me 10.809. So using 4 rectangles as a Riemann sum, we end up with 10.809. Now visually, what does this look like? Well, we set up all these midpoints here, and I'm going to connect each to the graph right above where the midpoint is, and that's the height of this first rectangle. Here is a second rectangle. Here is my third rectangle, and here is this last rectangle. So the area of this rectangle is literally this big. So this is 10.136 by 0.5, the area of that rectangle. The same thing here. This is 0.5 times this height, and in this case it's 6.20. This rectangle has a base of 1/2, and this height here is 5.052. This base is 1/2, and this height is 2.161. And so what we've done is we've just added up the 4 areas of these rectangles to get that the area of these 4 rectangles here is 10.809. Now this is just an estimate. Clearly we can see that these rectangles took into account some extra area and left out some other crucial necessary area. So now let's do this with integration. Let's verify how close our result was. So the integral from 0 to 2 of 9 minus 3 to the x dx is equal to 9x minus 3 to the x over the natural log of 3. And we evaluate from 0 to 2. So this is equal to 9 times 2 minus 3 squared over the natural log of 3. Then we're going to subtract from this 9 times 0 minus 3 to the 0 power divided by the natural log of 3. Well, 9 times 0 is just 0, so we're left with 18 minus 9 over the natural log of 3 minus 1 over the natural log of 3. And when you input this on your calculator, you get about 10.718. And as you can see, that's fairly close to our estimate using 4 rectangles. I hope this video has been a helpful example of how Riemann sums relate to integration.